Well, welcome back to our class on system design as we're looking at system and analysis for the application with this textbook, mostly thinking it from an information system point of view. And the way we have the material organized in this textbook, we have 4 phases. And so we're in the third lecture associated with the analysis phase, and we're going to be talking about data modeling. And then we'll have a relatively speaking, a short synopsis of what it means to normalize that data. And so we'll see that not in this lecture, but in the next lecture. So here's the objectives for this chapter, this lecture. We're going to be explaining the rules and style guides for creating entity relationship diagrams, ERDs. We'll then get some experience creating an ERD, describe how to use a data dictionary and metadata, explain how to balance ERDs and data flow diagrams, and then finally describe the process of normalization. The next lecture will go into details about how we actually do that normalization, so this will just be an introduction. So a data model describes the data that flows through the business processes in an organization. During the analysis phase, what we're going over now, the data model presents the logical organization of data without indicating how the data are stored, created, or manipulated so that analysis can focus on the business without being distracted by technical details. Later, during the design phase, the data model is changed to reflect exactly how the data will be stored in databases and files. But in this chapter, we will describe only entity relationship diagrams, and one of the most common data modeling techniques used in industry. So let's do some introduction and some terms here. First, a data model is a formal way of representing the data that are used and created by a business system. It shows the people, places, and things about which data is captured and the relationship among them. So a logical data model shows the organization of data without indicating how it is stored, created, or manipulated. And finally, a physical data model shows how the data will actually be stored in databases or files. So as we go over what we're doing here in the second phase, the analysis phase, and then get into future phases, we'll get into more perspective of all of those domains. So we're going to be talking about an entity relationship diagram, and it is a popular way to depict the data model. On an entity relationship diagram, similar kinds of information are listed together and placed inside boxes called entities. And we'll delve into what entity is in a little bit. Lines are drawn between entities to represent relationships among the data. Special symbols are added to the diagram to communicate high-level business rules that need to be supported by the system. And note that the ERD implies no order. So here's an example, and we'll get some perspective on how we go about reading an entity relationship diagram. And so what we have here, we've included a partial entity relationship diagram for the create preliminary customer drone order. And so this is something that you can refer into the textbook for more perspective, but drone tech is the example that we continue to go through in the whole textbook as we're coming back to that. So first we have organized the data into 5 main categories: customer, customer drone order, customer base model, order drone component, and drone component. So the customer data describes the organizations which are purchasing a drone tech commercial drone who wish to customize that drone to meet their needs. The custom drone order data capture information about every order for a custom drone. The drone base model data describes the characteristics of the base drone models specified in the order. The order drone component data describes each drone component the customer wishes to add to the custom drone or to replace standard components on the drone-based model. And then finally, the drone component data describes the custom components. So that just gives you an idea of what we're talking about here with an entity relationship diagram, giving some insight into a running example that we're using in our course and in the textbook. So we can use the ERD to show the business rules, and so the business rules are constraints that are followed when the system is operational. The ERD symbols can show when one instance of an entry must exist for an instance of another to exist. The customer instance must exist before customer drone order instances can be created for that customer, just to give you a perspective. And accordingly, a drone component instance must exist before order drone components instances can be created for that drone component. ERD symbols can show when one instance of an entry can be related to only one or more or to many instances of another entry. One customer instance can create many custom drone order instances. Each custom drone order instance is created by only one customer instance. A drone can be included on many chemical requests. A chemical request is for only one chemical. ERD symbols show when the existence of an entity instance is optional for a related entity instance. So like a customer instance may exist without being included on any custom drone order instances. So that just gives you a little bit of perspective. And so now let's use some of these terms that we've defined and that we're going to be utilizing by giving an ERD example. So here we have the entities. We are showing two, a customer and an order. So those are example. Each one has attributes. And so customer ID, name, address, and telephone for a customer, order ID, order date, and total order cost for the order, and then the relationship. The customer has placed the order, and so thus we can see the relationship and some of the syntax that we use for showing the relationship between entities. So what are the elements of an entry relationship diagram? There's the entities, there's the attributes, there's relationship, cardinality, and modality. We haven't talked about these last two yet, but we'll get into that in a little bit. So let's come back and define this a little bit more completely. An entity is a person, place, event, or thing about which data is collected. There must be multiple occurrences of this for it to be an entity. So keep that in mind. And you can see that these various things that student definitely would be an entity. You're going to run a class only if there is a minimum number of students, just to give you an idea using that as an example. So here is an example of a case entry for an entity. So we're talking about some kind of electronic tool that has syntax and rules for how you create an entity. So let's put this in the context of a data dictionary or metadata. As we mentioned earlier, a case tool is often used to help build ERDs. Every case tool has something called a data dictionary, which quite literally is where the analyst goes to define or look up information about the entities, attributes, and relationships on the ERD. And so this is a figure from the textbook, one of several that illustrate common data dictionary entries for an entity, an attribute, and a relationship. Notice that the kinds of information the data dictionary captures about each element also recognize that some of the entries in these examples are incomplete because often some implementation details are not decided until the physical data model is designed. And so we're going to come into that in chapter 10, so we'll have to wait for a little while for us to get to those details. Okay, what about the attributes? The information, this is the information that's captured about an entity. Only those used by the organization should be included in the model. And attribute names are nouns, and sometimes sometimes entry names are added at the beginning of the attribute name for clarity. Once again, here is another illustration from a case tool. You can refer to the textbook for this. This is for the entry for an attribute associated with an entity. So it's important that you understand what the attributes are. It's here we can be seeing a lot of information for a student: ID, last name, first name, address, date of birth, major, gender, grade point. And so all of these things can have, like, some of these can have sub attributes, like an address would be street, city, state, zip, and other things. Maybe there's a major, maybe there's a minor. There could be kind of several nuances that are utilized in some of these details. But what about the identifier types? One or more attributes can serve as an entity identifier, uniquely identifying each entry instance. Concatenated identifier consists of several attributes. An identifier may be, quote, artificial, such as creating an ID number, and the final decision on identifiers may be postponed until the design phase. But you can see some examples of what we might be able to think about for identifiers in the illustration on that slide. Well, we also have the relationship. There's this association between entities. The first entity is a relationship is the parent entity, and the second one is the child entity. The relationship should have active verb names, and relationships go in both directions. Cardinality, we saw this on an earlier chart but didn't define it. Cardinality refers to the number of time instances in one entry can be related to instances in another entry. You can have a one-on-one relationship. That's one possibility. You can have an instance in an entry refers to one or more instances, so a one to n. Or you can have one or more instances in an entry referring to one or more instances, and so therefore you have a m to n possible cardinality relationship. Coming back to our case tool that we can refer to in the textbook, and this is showing the entry for relationships between entities. Here are example of binary relationships. And so an employee, say it's associated with a parking spot, a product line is associated with a product, student is associated with a course. First, it's a one-to-one. The second one is one-to-many. And finally, the one is many-to-many. Those are all possible ways that we can be sitting in relationships. Another term that we mentioned but didn't define until now is modality. This refers to whether or not an instance of a child entity can exist without a related instance to the parent entity. So not null, it's an instance in the related entry must exist for an instance in the another entry to be valid, and null, no instance in the related entry is necessary for an instance in another entity to be valid. Now thinking about the data dictionary and metadata. So every case tool has a data dictionary where the analysis goes to define or look up information about the entities, attributes, and relationships on the ERD. The information you see in the data dictionary is called metadata. And so metadata, if you haven't heard that term, is data about data. And metadata are stored in the data dictionary so that they can be shared. So we see another view of the case tool there that you can be reviewing. So what are some of the types of metadata captured by the data dictionary? You can have things about the entity, the name, definitions, special notes, user contact, analyst contact. For an attribute in the name definition, the alias, sample value, acceptable values, format, type, and special notes. And then we have relationship of the verb phrase, like included in, parent entity, child entity, definition, cardinality, modality, and special notes. So here we've seen a cardinality as 1 to n as an example of what would be possible that we could be utilizing. So now let's think about creating an entity relationship diagram. Drawing the ERD is an iterative process of trial or revision. ERDs can become quite complex, and there's 3 steps in building an ERD. First, you want to identify the entities. 2, add appropriate attributes for each entity. And 3, draw the relationship that connects associated entities. Okay, in terms of identifying the entities, you want to identify major categories of information. If available, check the process models for data stores, external entities, and data flows. Check the major inputs and outputs from the use cases, and then verify that there is more than one instance of each entity that occurs in the system. We can add attributes and assign identifiers. So this is a part of the work that needs to be done. You can identify attributes of the entity that are relevant to the system under development. Check the process model repository entries for details on data flows and data stores. Check the data requirements, so the requirements definition. You can look at the interview knowledge users and perform document analysis on existing forms and reports. Then we can select the entity's candidate identifier, but the final decision may be postponed until later, say like during the design phase, which could be quite logical to do it there. So you can notice the identifier selected for each entity. And so here's just another partial ERD that we can be thinking about. And we've seen some of this information before when we were discussing about this earlier, things that were related to that. Okay, identifying relationships. Start with an entity and then identify all entities with which it shares relationships. Describe the relationship with the appropriate verb phrase, and determine the cardinality and modality by discussing the business rules with knowledgeable users. So in terms of building tips, the data stores of a DFD generally correspond to entities. Only include entities with more than one instance. Do not include entities associated with implementation of the system. These are things that will be added later. There are also some advanced syntax things that we can be thinking about, the intersection entities. A new entity is created to store information about 2 entities sharing an M to N relationship. Remove the M to N relationship between the 2 entities and insert a new entity relationship between them. Create 2 1 to N relationships. Original entities are parents to the new children intersection entity. You can then name the intersection entity and migrate parent entity primary keys to the new entity as a foreign keys. Possibly this could be done with concatenated primary key as well. So that just gives you some more perspective of what we can be doing and utilizing advanced syntax. So here we are looking at how to resolve M to N with an intersection entity. And so here we have a student, it registers for a course, but when we can have something in the middle here, a course registration, and so we can have that as another element that we can consider as we think about how we're going to lay things out. This is some more support information that you can be looking at. And so here we have customer drone order to the drone component. And here we have the customer drone order, and we stick this order drone component in between the two elements that are shown above. And so that would be another way that we could lay this out. We have some other syntax that we can be thinking about: an independent entry, non-identifying relationship, dependent entity, and identifying relationships. An independent entity is an entity that can exist without the help of another entity. When a relationship includes an independent child entity, it is called a non-identifying relationship. There are situations when a child entity requires attributes that the parent entity requires attributes from the parent entity to uniquely identify an instance. This is called a dependent entity. When relationships have a dependent child entity, they are called identifying relationships. Okay, for validating an entry relationship diagram, creating ERDs can be pretty tough. There are some general design guidelines that you can keep in mind as you build ERDs. Once the ERDs are drawn, you can use a technique called normalization to validate that your models are well formed. We'll just touch on in this lecture, and then the next shorter lecture, we'll get into that in more detail about how you go about normalization. So what are some of the design guidelines that we would want to be utilizing? Best practices rather than rigid rules. Entities should have many occurrences. You want to avoid unnecessary attributes. Clearly label all components. Apply correct cardinality and modality. Break attributes into the lowest level needed. Labels should reflect common business terms, and assumptions should always be clearly stated. So here are some data modeling guidelines that you can look over. So we have an example here in an academic context. For one, the country has only one instance. And so this may be a concern that we want to modify. Two, if teachers are called professors, then the ERD should contain an entity called professors to remain consistent. Three, why are all of these attributes being captured about the university? Will it be necessary to store the founder and its first president of each university and this other stuff? Thus, you can see that there's some stuff that's not necessarily needed, and we want to be thinking about that. The attributes in the subject entity are poorly labeled. For one, we have no way of knowing to which entity they belong. If they stood alone, it would be helpful to begin each attribute with sub, underscore, and stuff like that. And so you can see how we're picking at this a little bit, at trying to figure out if we've got the best approach for data modeling. For here, the name attributes really should be broken down into last name and first name. Otherwise, there would be no way to manipulate names in the system. And finally, the model assumes that a teacher can only work for one university. What about those who have joint appointments? So those are just some thoughts you can be thinking about that gives a more of a specific example and what can come up to give you some data modeling guidelines that we can be thinking about. Okay, normalization is a process whereby a series of rules are applied to logical data models on a file to determine how well formed it is. Normalization rules help analysts identify entities that are not represented correctly in a logical data model, or entities that can be broken out from a file. 3 normalization rules are described in the appendix, and this is what we'll have in a separate short lecture, and so you can refer to that. You want to consider balancing ERDs with data flow diagrams. All analysis activities are interrelated. Process models contain 2 data components, data flows and data stores. The DFDs data components need to balance the ERD's data stores, that is the entities, and data elements, that's the attributes. And many case tools provide features to check for imbalance, and so that can be helpful. Check that all data stores and elements correspond between models. The data that is not used is unnecessary. We had an example we showed 2 slides ago that maybe it'll help to elucidate that. Data that has been omitted results in an incomplete system, and do not follow thoughtlessly. Check that the models make sense. That's an important thing for us to always to consider. Here we're using something called a CRUD matrix, create, read, update, and delete. A useful tool to clearly depict the interrelationships between processes and data models is the create, read, update, and delete, or CRUD matrix. The CRUD matrix is a table that depicts how the system processes use the data within the system. It is helpful to develop the CRUD matrix based on the logical process and data models, and then revise it later in the design phase. The matrix also provides important information for program specifications because it shows exactly how data are created and used by the major processes in the system. And so this is just trying to illustrate an example of that process. All right, so this is what we covered in this chapter. So a little bit of a review. Define the meaning and purpose of the entity and relationship shown on an entity relationship diagram, ERD. Explain the meaning and purpose of attributes included in a data model. Explain what is meant by an entity's identifier. Explain the meaning of the cardinality and modality of a relationship. Explain the concept of metadata, about data, and how it is compiled in the project's repository. Discuss the process used to create a data model. Describe how to ensure that the process model and data model are balanced through the use of a CRUD matrix. And finally, discuss how the normalization process is performed and how it contributes to the quality of the data model. And like I said, we'll get into that in another lecture. And so please feel free to refer to that for the normalization process. So these are the terms that came up for this chapter. So please feel free to review this, or even better is go to the textbook and you'll get a chance to get a lot of details and not just the high level portions that we have for this lecture. All right, thank you very much.